Hi, welcome back to my channel, Physics from 5 KSSM. We continue Chapter 1, Force and Motion 2 on topic 1.3, Forces in Equilibrium Part 2. Learning standard for this topic is solve problems involving forces in equilibrium. So I will discuss some of the example and explain a method how to solve the problems involving forces in equilibrium. And according to the examples that I will discuss later, all involve three forces in equilibrium. Look at example 1. Figure 1.26 shows a stationary lamp hanging from two strings. The tension T is 8 Newton and the string is inclined at angle 60 above the horizontal. This one, Calculate magnitude of tension P and weight of lamp W. Okay, so look at diagram here. So I hope you still remember in last topic we have discussed about how to sketch a triangle of forces. So for this one, let's try to sketch. This is for the weight, vertical downward, W. At angle 60 from horizontal, we draw T. And then continue P. So this one is the triangle of forces for the forces that act on the lamp. Okay, we want to discuss three methods. The first method is using resolution of forces. Look at this diagram. So for resolution of forces, we just resolve for the force which is at certain angle from horizontal or vertical. For the forces which are already horizontal or vertical, that one no need to resolve. Hanya yang ada angle sahaja kita resolve. Yang horizontal, yang vertical tak perlu resolve. Okay, now we want to resolve T. Okay, the vertical component, this one is Ty. And the horizontal component is Tx. So you can see the force T is inclined upwards towards left. So the component also is upwards and towards left. Okay. So now we try to answer the first one. We want to determine tension in the string P. We want to find the value of tension P. So once you already resolve, meaning the tension T now represented by Tx and Ty. When you look at from the forces that act on the lamp now, because of the forces are in equilibrium, thus the forces are balanced. In this case, we have vertical component and horizontal component. Resultant force equals to 0 means vertical components of force are balanced, horizontal component of force are balanced, meaning upward force equals to downward force, the right side force equals to the left side force. Thus, we get from here, tension in the string P equals to Tx. And weight of the lamp W equals to Ty. So that will answer the question. A, the resultant force of the horizontal forces equals to 0. That is, the horizontal forces are balanced. Thus, P equals to Tx. How to find Tx? I hope you still remember how we resolve the force. By using this angle 60, the horizontal component Tx equals to 8 cos 60. And this one equals to 4 Newton. For the value of W, this is the vertical parts. So the vertical part also forces are balanced. Resultant force equals to 0. Thus, we can state W equals to Ty. Ty is the vertical component. For using angle 60, W equals to Ty equals to 8 sine 60 and equals to 6.93 Newton. So this is the method that we use here, is resolution of forces. So you just resolve the T and then the rest using the concept of resultant force equals to 0. Okay, method 2, we use scale drawing. I hope you still remember there are two methods of scale drawing. Either you draw a triangle or parallelogram. For this one, we want to draw a triangle of forces, but by scale drawing method. Okay, the first step, choose a scale. You choose a scale, you must check the magnitude of force here. Okay, so T given is 8 Newton. Step 2, draw a vertical line downwards representing W and a horizontal line to the right representing P to form a triangle. Measure the length of the side of the triangle. Use scale you have chosen to calculate magnitude of force. Okay. Now we don't know what is the value of P, what is the value of V. We just have the value of T. Let's say we choose the scale 1 cm equals 2 Newton. Now we want to start drawing T. Okay. So here the length of T will become 4 centimeter. Okay. Let's say we have a reference line, horizontal line. I draw it broken line to differentiate with the vector line later or the force line. Okay. Use protractor, measure 60 degrees. And then use ruler, measure T accurately 4 centimeter. And then end of the force T, continue drawing P. P is horizontal. We don't know the length, we just simply draw a longer line first. Okay, and then now we want to draw W. W is vertical, meaning from here you draw a vertical line to the line of force P. Okay, so we get like this. Okay, so you can see the two lines that we draw a bit longer just now intercept here, meaning this part and this part will become extra line. You can use eraser to rub off this part, so you will get a right angle triangle here. So this length of side, the yellow color, actually represent P, and this side represent W. So in order to get P and W, what you do? You just measure the length of P, you get 2 centimeter. Then multiply with the scale 2 Newton, thus you get 4 Newton. And then for W here, use ruler, measure the length, you get 3.5 centimeter. Thus 3.5 centimeter multiply 2 Newton, you get 7 Newton. Okay, so actually there are more than one method to sketch. So this is only one suggestion. I draw T first. Okay, okay, and then for the P and W, we don't know the length. We just simply draw a line which is longer. Then we look at the two lines will intercept it at one point. Okay. So this one is scale drawing. So for scale drawing, there must be scale. So make sure you have protractor, ruler, and pencil. Okay, in order to draw. Okay, method 3 is calculation using mathematical formula. Especially when the question come out in paper 1, you don't have enough time to use scale drawing. Okay, so now you can use mathematical formula to calculate. But for this method, you must know how to sketch a triangle of forces. We have discussed before how to sketch a triangle of forces. Then you choose suitable formula. If the right angle triangle is produced, you can just right away use Pythagoras theorem. If not, you can apply trigonometry, sine or cos, sine rule or cosine rule to solve the problems. Okay, so look at this one. We sketch a triangle of forces, so we get like this. W, draw W followed by P and then Q. This one just a sketch, so no need to measure anything, just sketch. So we get this one. So this is a right angle triangle. Okay, so now we want to find a P and W, so we can just straight away use sine and cos. If we use cos 60, then we get cos 60 equals to P divided by 8. Cos 60 adjacent divided by hypotenuse. Thus we get P equals to 8 cos 60 equals to 4 Newton. Okay, and then you want to find W, use sine 60. Sine 60 is opposite divide hypotenuse, plus W divided by 8. So you get W equals to 8 sine 60. So you get 6.93 Newton. Okay, so this one is quite simple because you get here is a right angle triangle. Okay, let's look at the second example. So we have a box of weight 50 Newton stationary on inclined plane. Draw a free body diagram of the box showing the weight of box W and normal reaction and frictional force Fr. Okay, let's try to draw first. So this is the box. Okay, now first of all you can mark, okay, directed downwards is the weight of the box. And then there is a friction. Okay, let's say friction is upwards because the box tendency is moving down. So this is the friction. Okay, and this one is normal reaction, 90 degrees to the inclined plane. Okay, so this one we call it free body diagram. Okay, B, by drawing a scale triangle of forces, determine magnitude of normal reaction R and frictional force. Now we want to draw the word drawing a scale triangle. Okay, so now set the scale. So the value of the weight here is 50 Newton. So I will choose 1 cm equals to 10 Newton. Okay, I will start drawing. I choose the vertical one, weight. Weight is 50 Newton. So this one, use ruler, measure accurately 5 cm. N of W, we want to draw the next force. Okay, W is at angle 40 with R. But we don't know the length of R, so we just simply draw a bit longer the line. Okay, and then for R is at angle 50 from the weight. Okay, so from here you can measure 50 degrees and then draw a line. We don't know the length, we just simply draw a straight line 90 degrees to R. Okay, so you can see the two lines meet here, meaning this part is a extra line, so you can just erase off. So we can see this one is the one that represents R, and this one is the one that represents FR. So how to get FR and R? Because of this is a scale drawing, again you need to measure. So FR, use ruler and measure, you get 3.2 centimeter. Then multiply with the scale, you get 32 Newton. R also same, measure the length, so you get 3.8 times 10 equals to 38 Newton. Okay, so this part we call it scale triangle of forces. Okay, so the extra line here you can just rub off. Okay, now next part. By resolving the weight of the box W into component parallel to inclined plane and perpendicular to inclined plane, determine magnitude of normal reaction and frictional force. Okay, now we want to resolve W. Parallel to the plane WX, perpendicular to the plane WY. As stated here, the box is at stationary on an inclined plane, meaning the forces that act on the box are balanced. From here we can say the vertical forces are balanced, or we can say the perpendicular forces are balanced, the parallel forces also balanced. Okay, from here. Okay, so because of that, we can state that R equals to WY, FR equals to WX. Thus, we can get the result, the answer. R equals to WY, WY equals to 50 cos 40. This is 40. Angle here is also 40. Okay, mathematics. Okay, so you will get 38.30 Newton. For FR equals to WX, thus equals to 50 sine 40 equals to 32.12 Newton. Okay, so this is using the method required. Okay, if they want you to, if the question started there drawing, so you need to draw. Okay, if no mention about drawing, meaning you can choose to use either resolution, okay, methods, or you can use mathematical formula to solve it. Okay, but if stated clearly resolving, so you need to resolve. If stated here drawing, you need to draw. Okay. Example 3, figure 1.30 shows a poster hanging on the wall of the lab with string and nail. Okay, weight of the poster 12 Newton. Sketch the triangle of forces for the weight of the poster and tensions in the string. Calculate the value of T. Okay, so you have here same, because of at same angle and they use the same string, so tension here are the same. Okay. Okay, let's look at the triangle of forces. So we draw the weight first onward. 12 Newton, the weight. This is not drawing, this is sketch. If drawing, you must set scale. This is sketch. So you just sketch. Okay, W, then end of W. Continue drawing T. T is 35 degrees from horizontal. And then draw T. So T always 35 degrees from horizontal. Then you complete the triangle. So this is the triangle of forces for the weight of the poster and tension of the string. Okay. Okay, let's see now. Calculate the value of T. Because of we just sketch, now we use this triangle to solve or to find the value of T. Okay. From here, we cannot use Pythagoras theorem because this is not a right angle triangle. So if this one is not right angle triangle, you can use either sine rule or cosine rule. If you look at the sine rule will give you the ratio of the side. Let's say this side is equals to ratio the length of side over the opposite angle. Sine opposite angle equals, okay, always constant. So we had T divided by sine. T here. Angle here is 55. Okay. Angle here is also 55. Okay. Thus T divided by sine 55 equals to, W here is 12. 12 divided by sine 70. 35 plus 35. So we get 30. Then you can solve for T. You get 10.46 Newton. So this one we call it sine rule. Sine rule is, if you use this side the length is T, or the magnitude is T. T divided by sine of the opposite angle to that side. Okay, equals to T divided by sine of the opposite angle to that side. And then equals to W divided by sine of the opposite angle here. Okay, so we get the answer. Or using cosine rule, we can use, okay, this is the longest side. So W squared equals to T squared plus T squared minus 2 times T cos angle between the 2T. Here is 7T. Okay, so we get the answer. Solve this one, you will get T equals the same answer, 10.46 Newton. So I think you better try at least once to use this method, because sometimes this method will help you to solve, especially for paper 1 question. Okay, this is the sine rule and cosine rule. Okay, for those who still don't know about this rule, you can find this in the mathematics book. This is not for right angle triangle, meaning non-right angle triangle. Okay, sine rule, you can say A divided by sine A equals to B divided by sine B, C divided by sine C. Okay, this one is for finding sides. Kalau cosine rule, this is cosine rule. Cosine rule is the longest side A equals to B square plus C square minus 2BC minus 2BC cos A. For example, you want to find sine A. So sine A, dia punya pair angle ialah A lah. Okay, opposite angle dia. So this one is A squared. So the angle is A. Okay, so this is sine rule and cosine rule. So you can use to solve problems for forces in equilibrium. Okay, now check the formative practice 1.3. So you can go and try first, then only you can come back and check the answer. The number 1, state the meaning of forces in equilibrium. So all forces acted in the object are balanced, and resultant force of the forces is 0. Okay, now the next question, number 2. Figure shows a block that is stationary on inclined plane. Stopping force P is applied horizontally. So this one. A. Sketch and label weight of block and normal reaction from the surface of plane R. Okay, you want to draw 2 forces only. So we have weight downward, normal reaction 90 degrees to the inclined plane. So this is A. And then sketch the triangle of forces for P, W and R. I will draw W first, the vertical one. Okay, end of W, I will continue drawing P. So this is P, and then R, this is 30 degrees, meaning angle between R and W is 30. Thus, at angle 30, draw R. Okay, so you can see this is a triangle of forces for force that act on the block. Always remember, for forces in equilibrium, you need to arrange the forces so that it will form a closed triangle. Looks like they are moving in the same direction or move in the circle. So this one we call it closed triangle of forces, meaning forces are balanced or resultant force equals to 0. So that's all for this topic. To understand better, you need to do a lot of question on this, because there are so many type of question that can come up. So okay, try your best to understand all the method that discussed in this video. Okay, that's all for now. Bye.